Hello Worthington Juniors, this is your Pythagorean Theorem review for your MCA. So let's just start with what the Pythagorean Theorem is. First of all, it says in a right triangle. That's actually the most important thing. You have to have a right triangle or some kind of right angle before you can even use the Pythagorean Theorem. So be sure you have a right angle before you consider using the Pythagorean Theorem. Right, it is defined as the square of the length of the hypotenuse, which would be equal to the sum of the squares of the lengths of its legs. Well, first of all, we have to know what is a hypotenuse. A hypotenuse is the longest side of the right triangle. It is always going to be across from the right angle. So if you have the right angle, if you go directly across, that's the hypotenuse. So in this picture, the hypotenuse is defined as C. The other two sides, the two sides that form the right angle, are called legs, and those are simply A and B. Those are pretty interchangeable. C is what's important. In the formula, a squared plus b squared equals c squared. C squared is the one that's all by itself. That's the hypotenuse. That's the one that's across from the right angle. Real quick, if you're asked what a Pythagorean triple is, a Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared. The important thing is that they are integers, no decimals. For example, 3, 4, and 5 are Pythagorean triple because 5 squared equals 3 squared plus 4 squared. So, here we go. Let's try just using the Pythagorean Theorem a few times, making sure we understand how to use it. The directions actually say find the unknown side length, simplify answers that are radicals, and tell whether the side lengths form a Pythagorean triple. So, here we go. We have a right triangle, which means I can use the Pythagorean Theorem. So, to do that, I need to identify what's the hypotenuse. If I have a right triangle, right across from it is the hypotenuse. So this is going to be my C side. It's going to be the one that's all by itself. So what I'm going to do is I'm going to take those legs squared and add them together and set it equal to the hypotenuse squared. So to set up the Pythagorean Theorem, we're going to take x squared plus root 7 squared and set that equal to root 19 squared. Okay, a squared plus b squared equals c squared. The legs equal the hypotenuse, and we have to square them. X squared, we're going to leave that as x squared, plus root 7 squared. The root and the root and the square cancel out, and we're left with just 7 equals root 19 squared, which is simply 19. Now if we solve for x, we subtract 7, we get x squared equals 12. The only way to get x by itself is to square root. So we have x equals the square root of 12. That is a possible answer. You could type that in your calculator and get a decimal form, or if we take it a step farther, we know factors of 12 are things like 4 and 3, and what's special about 4 is it's a perfect square root. The square root of 4 happens to be 2. So the square root of 12 is actually equal to 2 root 3. So you have a couple of possible answers here. Root 12, 2 root 3, or your decimal form. Okay, let's try another one. A squared plus b squared equals c squared. The important part is being able to identify what is c. Hopefully you know what is c. I hope you think it's 13 because that would be correct. The triangle may be moved, flipped, whatever, rotated, but as long as it's across from the right angle, it's the hypotenuse. The two legs that form that right angle, well, are the legs. So here we go. We're going to have x squared plus 12 squared equals 13 squared. Let's simplify. X squared equals, x squared plus 144 equals 169. So if we get the x by itself, we're going to subtract 144, and we find that x squared equals 25. If we square root, we get x equals 5. So, I need to backtrack a little bit. We had an added direction that wanted to know, are they Pythagorean triples? That's just an extra definition, a little bonus for you. If you notice in this one, the answer would be no because we have square roots. We don't just have nice integers. Where in this one, we have side lengths of 12 and 13, and we found the third one to be just a 5. No square roots, no decimals. They're nice, pretty numbers. This one is not a Pythagorean triple because they are not nice positive integers. This one is a Pythagorean triple because they are all positive integers. Okay, continuing on, let's practice that Pythagorean theorem a little bit more. This one, if we notice, find our right angle and go across from it, x is the hypotenuse this time. So our legs are 6 and 5. So if we take a squared plus b squared and set it equal to c squared, that is the correct formula. Remember, every time we think about c, the number by itself, the side by itself, it's the hypotenuse, not the leg. So here we go. 6 squared is 36 plus 5 squared, which is 25, is going to equal x squared. If we combine them, we get 61 equals x squared, and if we square root, we find that x equals the square root of 61. Now, let me back up here. Before, when we took root 12, I found factors of 12 that had a perfect square in it. There are not factors of 61 that have a perfect square, so that's your answer unless you type it in your calculator and find a decimal version. Okay, let's try one more. Here is our right angle, so this is actually the hypotenuse. I know this is a square, but if you cut a square in half, you get a triangle. And just so happens that top half is a right triangle. So it's the bottom half, but the top half is the one with our variables. So what we're going to do is set up our legs are both x. So we're going to have a squared plus b squared. In this case, it's going to be x squared plus x squared is going to equal our hypotenuse squared. Now, what's important is this is 8 root 2. I need to put it in parentheses and square the whole thing. Everything gets squared. So if we simplify x squared and x squared, those are like terms. 1x squared and 1x squared makes 2x squared, which is going to equal, now if I square this, I actually have to square everything. I'm going to have 8 squared, which is 64, times root 2 squared, which is 2. Okay, so now we have 2x squared equals 64 times 2. So if we want to simplify, we can take 2x squared and set it equal to, well, 64 times 2 is 128. Divide by 2, we're going to be back at 64. X squared equals 64. And if we square root to get x all by itself, we get x equals 8. Meaning each side length is 8. They were the same in length this time. Alright, that's your Pythagorean theorem. Now, a couple other things you can do with Pythagorean theorem. There are word problems that involve it, but there are also area problems. Here's an example. It says find the area of each figure, round your decimal to the nearest tenth if you need to. So, here we go. What I know is I have one big triangle, but if you cut it in half, I have this right angle. So what I can do is find the height, because remember, to find the area of a triangle, you need to take base times height, and they need to make a right angle. If you don't have a right angle, not so good. So I need to figure out what this height is. So to do that, I get to use the Pythagorean theorem because I have a right angle. Now across from the right angle is 12. That's going to be my hypotenuse this time. I'm going to call this side h for height. So what we're going to do is take our legs, 4 and h, and set it equal to our hypotenuse, but we're going to square them all. So we're going to take 4 squared plus h squared equals 12 squared. So we have 16 plus h squared equals 144. So if we subtract 16, we get h squared equals 128. And if we square root, we get h equals the square root of 128. Now again, you could be using your decimal approximation if you want. I'm going to continue on with exact. So h is going to equal the square root of 64 times 2. 64 times 2 is 128. We just did that earlier, and we get the fact that h equals 8 root 2. Now, did that actually answer the entire question? Well, no, that is simply the height of the triangle. So what I have found is that this length is 8 root 2. Now to find the area of the entire triangle, I'm going to have to take the entire base and multiply by the entire height. So area of a triangle is 1/2 base times height. So let's plug in what we know. Area is going to equal 1/2 times. How long is the base? This part was 4. Well, so is this part. So the whole base is actually 8 units long. 8 inches in this case. Height is the number we found, which was 8√2. So if we continue, area equals 1/2 of 8, which is 4, times 8√2. 4 times 8 is 32√2. That is the exact area. This is in inches squared. Go ahead and use your calculator and find your decimal approximation. Take 32 times the square root of 2, hit enter, and you'd have your decimal approximation. Nearest tenth, 1 decimal place. Okay, let's find the next one. This is an irregular shape. So if you remember how to find areas of irregular shapes, what you need to do is cut it up into shapes you know. Those would be squares, rectangles, circles, triangles. In this case, I'm going to draw a line here and split it into a rectangle and a triangle. And the way I'm going to draw on the line, I'm going to make sure that that is a right angle. So what I have is this rectangle, which is 10 by 12. So the area of a rectangle is length times width. So this area is simply 10 times 12, which is 120. This triangle, well, we have to have the base and the height. What's this base? Well, if this whole side was 18 and I cut this off after 10, this side left in blue is simply 8. What's the height? Well, actually the height is 12. We don't need the Pythagorean theorem here. When would we need the Pythagorean theorem? And the answer to that would be if I was asking you to find perimeter and not area. But we were asked to find area, so let's continue on. So the area of this triangle is going to be 1/2 base times height. So the area of this is going to be 4 times 12, so 48. So the area of the entire shape would be 120 plus 48, the area of the rectangle plus the area of the triangle, which would be 168 centimeters squared. So, the last one didn't really have Pythagorean theorem in it. You may think you need to use it, and you maybe do, and sometimes you don't. Things to keep in mind with Pythagorean theorem. You have to have a right triangle. You have to have some kind of perpendicular line, some kind of right corner. Next, you have to make sure that when you use a squared plus b squared equals c squared, the c, the one all by itself, has to be the hypotenuse, and the hypotenuse is the one always across from the right angle. So make sure you have the right side plugged in to the right spot. All right, that was Pythagorean theorem. Good luck.